Welcome back. Now that we have animations for when we're holding a sword, we really want to pick that sword up. That's our goal. And to do that, we have to attach the sword's root component, which is the item mesh itself, to our hand socket. We called it right hand socket on Echo's skeletal mesh. So we're going to learn how to do this in Blueprints first before we do it in C++. So let's see how we can do this. First, we're going to go into our Blueprints folder, into Items, Weapons, and open BP Weapon. And for now, we're going to disconnect this pin to Add Actor World Offset. We don't want the item hovering up and down once we've attached it to the hand. We'll learn later how we're going to implement the hovering capability and disable it once the weapon is equipped, but for now, we'll just disable it to make things easy. Now, we know that the sphere component has onComponentBegin overlap, and in C++, we have a function callback that will respond to it. But we'd like to see how we can attach this weapon to the character from Blueprints first. So I'm going to select the sphere component, right-click in the event graph, and type onComponentBegin overlap, and get this event. And when we overlap with another actor, we want to make sure we're overlapping with our slash character. So we can take the other actor that we have access to and cast it to a slash character. Now, if the other actor overlapping with this weapon is a character, then we'll now have the value of that other actor cast to the slash character type. So what we can do is drag off of other actor and type cast to, and we can search for slash character. And here in Blueprints, we can cast to the C++ class slash character or the blueprint slash character. I'm going to choose the blueprint BP slash character. And if the cast is successful, in other words, if other actor is indeed a BP slash character, then this execution wire will execute. If the cast fails, then the cast failed execution wire will execute. Now we're interested in when the cast succeeds. And if the cast succeeds, we have access to the other actor cast to a BP slash character, which means we can access properties on that character. Now, in order to attach this weapon, specifically the root component, which is the sword mesh called item mesh, we need to access the slash characters mesh. And we also need to access the item mesh here in the event graph. Now, if I take my item mesh from the components panel and drag it out into the event graph, I can drag off of item mesh. And there are a number of ways in Unreal Engine to achieve attachment. One of those ways is by the use of a function called attach component to component. If we select that, we have this function that takes a number of inputs. It takes a target, and notice that the function says target is scene component. That means this function is a function that belongs to the scene component class, and it's obviously exposed to blueprints, so it's blueprint callable. So we're taking the item mesh and calling the function on it, attach component to component. And the item mesh is our sword here. We want to attach this to the mesh on slash character. And we can get that mesh because slash character has a mesh variable. And if we drag off of as BP slash character, we can type get mesh, and we see that the mesh is accessible here. And if we take this mesh, we can drag it into the parent input, and hovering over parent, it says scene component, object reference, parent to attach to. So this function will take our item mesh, the sword mesh, and attach it to the scene component, which is called parent. And notice there's another input of type name called socket name. We can specify a socket on this scene component, and this scene component is the character's skeletal mesh component, which does have a socket. We added the socket, which we called right hand socket. So we're going to enter that text here for the socket name. Now we have attachment rules. You see, when we attach a component to another component, we need to decide how that attachment should take place. Should the component we're attaching keep its offset relative to the component we're attaching to? Well, in our case, we don't want to keep the relative offset. We want to actually snap to the target And if we open the dropdown, we have some options. We have keep relative, keep world, and snap to target. Snap to target is what we want. That's what's going to allow us to attach this sword to that socket and see the position that we've seen when previewing the mesh in the animation editor. So for location rule and rotation rule, we're going to snap to target, and we'll go ahead and set the scale rule to snap to target as well. Now, hovering over these inputs, we see that their type is E-attachment rule. That's an enum. So we'll keep that in mind as we go into C++. We're going to probably see that E-attachment rule type somewhere in C++. Now, the final input is a Boolean called weld simulated bodies, and it says whether to weld together simulated physics bodies. That matters if we're simulating physics, but none of these components are simulating physics, so we can leave it checked or unchecked. It doesn't really matter. Now we're going to hook up the execution pins so that as soon as we overlap with this sphere with our character, our cast will succeed and we'll call attach component to component. Let's go ahead and compile. Now, as soon as we compile, notice we get an error. And if we hover over the error, it says this item mesh is not blueprint visible. And in parentheses, it's telling us blueprint read only or blueprint read write. Remember, those are the uProperty specifiers that we have to give a variable for it to be visible in the event graph. Let's go look at our C++ file and go into item.h where the item mesh is declared. Notice that it's private and it's visible anywhere. Visible anywhere exposes it to the details panel, but not the event graph. If we want it visible in the event graph, we have to use blueprint read only or blueprint read write. And if we use one of those, we need to add the meta specifier in order for this private variable to be exposed to the event graph. We can either do that, or if we don't want to add this meta specifier, we can make item mesh protected or public. Now, I'd like to make it protected actually, because when we implement this in C++, we're going to want to access item mesh from within the weapon class, which is a child of item.h. But private variables are not accessible to child classes. We can't access item mesh from within weapon unless it's protected or public. So I'm going to take item mesh and move it up to the protected section. And in order to expose it to the event graph, I'd like to make it blueprint read only. If I wanted to be able to set it and change its value from blueprints, I would make it blueprint read write. But for now, we just need to access it. We don't need to change it. So we'll make it blueprint read only, and I'll save all from Visual Studio and hop back into the editor and hot reload. Now, after hot reloading, going back into BP Weapon, I can compile without errors. So let's see how this works. I'm going to press play and run up to the sword and take a look. It's attached to our right-hand socket and it moves along with us. And because this sword static mesh is the root component for the weapon, if I hit tilde and enter the console command show collision, I can see our sphere component and it's moving along with the sword static mesh because it's attached to it. So we've effectively attached the root component, the sword, of our weapon to that socket on Echo's skeletal mesh, which is great. So that's the next step, is attaching that sword. It looks like we've equipped a sword, which is awesome. But we want to do this from C++. We now know how to do it from blueprints. Let's go about doing this in C++. So I'm going to go ahead and remove these nodes, simply delete them, and hop back into C++. And we'll go into our weapon class. And here in onSphere overlap, we'd like to do the same thing we just did. Now, the first thing we did in blueprints was we took that other actor, which we have access to here in onSphere overlap. It's passed in when the delegate loops through its delegate list and calls all bound callbacks, including this one. So since we have access to other actor, we can cast it to a slash character. Now, our class slash character exists in the characters folder. It's in slash characters, and the header file itself is called slash character.h. So we're going to include that type since we're going to use it here. So we'll add to the includes characters slash character. So we don't have to go through all the folders in the path. We can just include characters. Everything in the public folder is accessible from here, so we just need to specify characters/character.h. Now we have access to that type, and we can cast other actor to a /character. Now to do that, we use Unreal Engine's cast function called cast, which is a template function which requires us to tell it what we're casting to, and we want to cast to an a/character. And then in parentheses, we put what we're casting. We're casting other actor. So this cast will return an a/character if the other actor is indeed a /character object. Otherwise, if something else overlaps with our sphere and it can't cast to a /character, this cast will return null. Now, we're going to store the return value from this cast in a local variable of type a/character. So we'll make an a/character pointer called /character. And we'll assign the value returned from the cast. But we should always check to see if this cast succeeded, which means we're going to check the /character pointer to make sure it isn't a null pointer. So we'll say if /character. And if we make it inside this if check, then the other actor was indeed a /character object. And now we can go to work attaching our item mesh on the weapon to the skeletal mesh on the /character. Now remember that function attach component to component. It belongs to the scene component class. And we used our item mesh. We'll do the same thing here. We're going to take item mesh, and we can access it here in weapon because we moved it to the protected section in item.h. If we hadn't done that, if we had left it in private, we wouldn't be able to access it. In fact, I'd like to show what happens if we leave item mesh in the private section. So we'll move it down there and save and come back to weapon, and now we get red squiggles. And the pop-up says this member item mesh is inaccessible. That's because it's private. So we do need it to be protected. So we'll move it back up there. So item mesh can be protected. And now from weapon, we can access it. And we can use the arrow operator on this pointer to call the C++ version of that function we called in Blueprints. In Blueprints, it was called attach component to component. But in C++, the function is called attach to component. Now, let's open these parentheses and see what inputs we need. First, we need a scene component. We need to specify the component to attach to. We want to attach to the /character's mesh. And the mesh on the character class has a public getter. That public getter is called getMesh. So we'll take our /character pointer and use the arrow operator calling getMesh. So that's our first input. Now, I can see the other required inputs by holding Control-Shift-Space, and that'll pop up this pop-up again showing me what the input parameters need to be. The next one is a const f attachment transform rules called attachment rules. Now, typically when you see f, that means it's most likely a struct. Now, if we make some room here and create an f attachment transform rules struct called, say, transform rules, we'll see that we get an error. And the error says no default constructor exists for this class. A default constructor means we can create an object of this type without passing anything into the constructor. In regular C++, sometimes you'll see the constructor called directly like this. Now, this particular class has constructors that require input parameters. I hit Control-Shift-Space to see the pop-up, and we have one of 4 here indicating that this struct has 4 different overloads to its constructor. And we can go up through these different constructors. Now take a look at 4 of 4. This constructor overload takes an E attachment rule. That's that enum we saw in Blueprints. And then it takes a Boolean called weld simulated bodies. Again, one of those parameters on the Blueprint function attach component to component. So we can create an F attachment transform rules with its attach rules configured. This overload will set those 3 rules, location rule, rotation rule, and scale rule, to whatever we pass in here. And we can pass in that enum by entering e attachment rule ::, and we can see the different options here. Now, if you're not used to using enum constants fully qualified with the enum name like this, that just means that this particular enum is a scoped enum. Scoped enums require you to fully qualify the enum constants with the enum name like this. In fact, we can right-click on this enum and peek the definition, and we can see that it's declared like this. Regular enums just say enum with the enum name, but scoped enums have the class keyword here. If you have the class keyword, then that means every time you try to reference one of the enum constants, you have to provide the full enum name with the scope resolution operator. That's the 2 colons there. So this is a scoped enum. This uint8 part means that its enum constants will have the internal type unsigned integer 8-bit. It's a way to keep these enum constants small. So since eAttachment rule is a scoped enum, in order to use any of its enum constants, we have to fully qualify those constants with the enum name. And we want snap to target. As we saw, that's the correct attachment rule that we want. And hitting Control-Shift-Space, I see that this constructor overload requires that Boolean for weld-simulated bodies. We can simply pass in true, as that's what we did when calling the blueprint. We left that checkbox checked. So attach to component, clicking in the parentheses and Control-Shift-Space to see the pop-up, we now have something to pass in here for the transform rules. It's our local variable called transform rules. We'll pass that in. Now, the last input is an fname, and we see that it has a default value name none. So if we didn't care about attaching to a particular socket, we just wanted to attach to the mesh itself, we would leave this argument out when calling this function. But in our case, we do want to attach to a particular socket. So we're going to pass in an fname with the value right-hand socket. So we're specifying that we should attach to the right-hand socket. So after calling this function, we'll attach our weapons item mesh to the /characters skeletal mesh at this socket, right-hand socket. And that's it. This is the C++ version of what we did in Blueprints. So now we can compile this. I went ahead and closed out of the editor, and I'm going to Control F5 to do a hard compile from Visual Studio. It's a good idea to do that from time to time, so we're going to do that now. All right, so we're back in the editor. I can press play, and let's go ahead and overlap with the weapon. And now we have our weapon attached, and this is great. So we now know how to do this in Blueprints and C++. We're that much more powerful. And if we wanted, we can go to our character, open the characters folder, open BP/character, and choose the mesh, and we can play that idle animation from Mixamo that we retargeted. So we can change animation mode to use animation asset and choose standing idle retargeted. That way, once we pick up the weapon, we can see how it looks. I'm going to press play, and yes, we're now just using a single animation, so we're sliding around and we remain stiff when we jump, but I just want to see what it looks like when I attach the sword. And as I expected, it looks phenomenal. So this is great. Okay, so I'm going to go ahead and select the mesh and select Use Animation Blueprint so that we're back to using our ABP Echo animation blueprint. And now we have attachment of that sword to the mesh at the right-hand socket, and it looks awesome. So we're one step closer, but we still can't swing the sword, so there are still a few things we need to take care of, but we're slowly getting there bit by bit, and getting stronger and more capable all the time. So excellent job. I'll see you in the next video.